In the first part of the video, I explained how to debug the chain processes by Locker Goga. As we know, Locker Goga uses a master-slave model to operate. Master process sends the task to slave process and create them in order to make them encrypt users' files on computer. And in the second part, I'm going to explain how to find algorithm IDs that are supposedly used to encrypt the file's content and encrypt the keys data. And supposedly Locker Goga uses symmetric and asymmetric cipher to do that. And now we are going to find out what these ciphers are. Currently, I'm debugging the worker process, and as you can see, the master process sent a pass to file name, and the worker is about to rename the file and start encrypting the data in the file. And it's actually a good starting point for us to investigate the ciphers used in this ransomware. To do that, I suggest to switch to strings window. And first, we know that Locker Goga has a Crypto++ library statically linked into its body. To prove that, we can try to find strings that contains the name of the library. For example, here we have a Crypto++ RNG random number generator. And then let's find strings that are related to encryption. So, for example, here we can see the string. This object requires an IV. IV stands for initialization vector used by AES. This is a symmetric encryption standard. So supposedly this string is used in throwing an exception from the Crypto++ library. And my goal here is to set up breakpoint first in this function that checks and throws exception if IV is invalid. And the second is using the string, we can find the place in the Crypto++ library source code and see what is inside of the function, how can we use it to get the algorithm ID. So I'm switching to Visual Studio, where I have open source code. So now I'm in Visual Studio with opened Crypto++ project. So this is a crypto library, and let's find the string that we saw in IDA in one of the functions. And Visual Studio found one match which is good for us, and this match is about checking our cipher object, and if it doesn't meet the condition, this function throws an exception telling that the argument is invalid, and the parameter which is sent as a part of the exception is a string, and this string is created using algorithm name. This is the first part of the string, and the second part is a description of the problem. So here we have like the problem that the object doesn't have an IV. So as this string contains algorithm name, so we can, if we make our program call this exception generation function, we can get the name of the algorithm in this class. And I'm back to IDA and ready to resume application, and see if we can through an exception that will generate for us algorithm name. So the first condition checks the object, and it actually goes to the end of the verification code without throwing an exception, and the exception is thrown in another branch. So here we have the method generation code. So therefore I don't want to go this branch, which says us it's everything's okay, but I want to set up IP to another branch and go to the exception generation code. Supposedly this is the call to get the algorithm name, and if we go to EAX register, CPU register, so we see the string which represents the algorithm name, and it is AES CTR. CTR is a counter mode for Advanced Encryption Standard, which is actually streaming mode. This mode supports streaming encryption, which is strange because typically ransomware they use CBC block encryption, but in this case we have CTR. Okay, next let's find any string related to public key encryption. For example, here we have a message. This key is too short to encrypt any message for this public key. So let's go to the reference where this string is mentioned, and again set up breakpoint before in the first condition here, so we can alter the execution order and make the exception code run. So we need to go there, and before we go we need to study the source code. Let's copy the string and search it in the source code. So I am in Visual Studio again, and let's find for the next string, and as you can see this is another check that is performed inside of the encrypt function. This is encrypt function is a part of trapdoor function encryptor base class, which is if we go to declaration, so we can see that it derives another class, cryptosystem base, which is simply interface for trapdoor function cryptosystem. So let's go back to our function, and here again we have our code that throws an exception about invalid argument, and this exception gets as an input algorithm name plus the message this key is too short to encrypt any message, or there is another branch which generate another message. So we can choose any of these branches to generate this string. So I am back in IDA, and let's resume to generate another exception and catch the public key cryptography algorithm ID. So we are in this function in the encrypt function of the trapdoor interface, and again it checks and tells us like everything is okay and doesn't want to go to our exception code. However, we can force it to do that. Supposedly it is here, so let's check EAX register. So here we have address, and here it is. The asymmetric algorithm is RSA, and it uses optimal asymmetric encryption padding with mask generation function SHA-1. So this is how simple we can get this information if we have the source code, and we can manipulate the execution order and make the code through an exception with the information that would help us identify the ciphers in ransomware.